Okay. All right. So I'm recording. All right. So welcome to day 11 of FoP. Today we're going to be covering um, big O notation. But to start off, we're going to finish off Pets.py. And today's going to be a simple code along as we work through it. Um, you guys will be helping me code along. I'll be taking your suggestions so we can see how we come up with a solution with today's code. This will be the last actual problem involving reading and opening or reading and writing CSV files. Let me go ahead and share my screen real quick. Okay. Yeah, so this will be the last official my bad. The last official problem. After this, we're gonna move to a completely different lesson that has nothing to do with this. So ask the questions that you have. I don't have a pre-built answer key for this one, so you guys will be helping me build this answer key today. So for this project, we're going to import JSON just like before. And then we're going to write a class named neighborhood pets. It has methods for adding a pet, deleting a pet, searching for the owner of a pet, and saving data to a JSON file, loading it from a JSON file, and getting a set of all pet species. Okay, it will only be loading JSON files it has previously created, so the internal organization of the data is up to you. Okay. Who would start us off with our neighborhood class and the first method that we're gonna have? Volunteer, please.
Init method.
Yeah. So we can go ahead. We can do the neighborhood pet class, and I heard an init method, so we'll give it the init method. And it takes no parameters, and we also don't really get much guidance on what kind of data members we should have. Correct. So who can give me a recommendation of how would you go about this? What kind of data members would you give it?
I'll just admit that was the part that I was struggling with. Figuring out how to start that.
Yeah, so not much guidance. So honestly, it kind of leaves it up to interpretation of however you want to take this and what route you want to go. I see here pet dictionary from Adrian. Yeah, that's a nice one. We can do pet dictionary. So we'll do self dot underscore. We'll make it private. We'll say all pets and we will assign that to dictionary, right? And we do dictionary. Why would we choose dictionary over a list over anything else? Well, why did you say dictionary, agent? He said I could picture it easier. Okay, yeah, you could picture it easier, sure. I guess that that would work for you. I think uh, for most people, a dictionary will work a little bit easier for this. In the manner that we can access it a lot easier in comparison to a list in which we don't know exactly where all the pets are going to be located at. And we'd have to find stuff by either index or looping through the entire list. Now, a neighborhood probably isn't that big, so a list might actually work in the situation. Uh, but good practice might be just using a dictionary instead. In the event that whatever our problem was working with was bigger than something as simple as a neighborhood. So we'll start off with a dictionary. We'll leave it empty for now. Next method is going to be adding a pet method. Let me get David Castle. Would you mind helping me out? How will we build off this method?
Yeah, sure. So, I took a little bit different of an approach, right? So I made a separate class for pets. Um, just because like pet is like always going to be the same. It's always going to have name, species, owner. I feel like that's a pretty good candidate for having its own class, right? And so what I ended up doing is instead of the dictionary for what you did in neighborhood pets, I had a list, and what I ended up doing is creating a new pet and then appending it to that dictionary. So if you go, hold on, yeah, so class pet underneath that definite, and it's going to be self name species owner. If you go to the parentheses on the right side of the init, it's going to take in the parameters name species owner. And then, yeah, just set those to name, species, owner, making them private.
This is a great method. I was working on it before. I did delete most of it. This is the same way I went. I would still keep the dictionary, but yeah, this is perfect. You know, we like to use the "don't repeat yourself" acronym, right? The DRY method. And this is a great example of how we don't want to repeat ourselves, so we can just create that class right off the bat and not have to continuously make different pets or um, we know that we're gonna have multiple bits. Why not just declare a class? Like, you just do the work for us and just hold it in some kind of an object, you know, an instance of that. And that's awesome. You went that route. I'm glad you guys are thinking that way. So we got the class pet. And now if we look at the readme says the add pet method is going to take its parameter, the name of the pet, the species of the pet, and the name of the pet owner. So adding to
Yep.
what David said, we'll pass in those exact parameters which can be given into the class, thanks to the way that was set up.
Yep.
Um, and we
And then
can
looking ahead at, oh, sorry.
no go ahead. Awesome, please take it
Yeah,
away. Yes.
looking ahead at the bottom of the bullet point there, if a pet has the same name as a pet that already been added, then the function should raise a duplicate name error. So I would go to the top of the document after import JSON and just set that up, do class duplicate name error, parentheses, exceptions, colon, indent, pass.
Outstanding. Yeah, exactly that. We want to go ahead and just declare our exception class up here. Get it out of the way, because we're going to know that within this method, we're going to try to raise an exception if we get an issue. So we'll do just that. We can go and check if the name that is being passed into this parameter already exists within the neighborhood pets that we have. So we can say if name in self dot pets, that would check if it's in there. We can raise the duplicate name error exception and just say exactly like pet name already exists in the neighborhood. Am I spelling that right? Name. Did I spell name? Damn, dude, I'm dumb, bro. How do you? He said neighborhood. Neighborhood. Okay, there you go. I apologize for that. Yeah, so neighborhood. Pet name already exists in the neighborhood. Right, we'll raise that exception. Else, we will go ahead and create the instance of that pet that uh, we just found out we have to create. We can do new pet is equal to call the class pet that we declared outside of this class, uh, and it will take the name, species, and owner, and that will create that new pet, right? So now we have that new pet, and we want to ensure that we add it into our current pets. So we will do self dot underscore all pets and assign it a key value pair. Now, how do we want to do this? Well, it's pretty much up to our uh, however we want to go about it. And I think the easiest way of doing it from reading through the README is that we're going to be checking this pet name multiple times. So maybe we want to assign the key as its pet name, and for its value, we can hold the entire object. So pet object, right? We can do it like that, and I do this to remind myself what that holds in there. So in the self dot underscore all pets dictionary data member, I can go ahead and use the key name, and then do the equal sign to assign it a value, and I'll pass it the new pet we just created. And yeah, and I believe that should conclude the add pet method, right? Yeah. Any questions on how we did this? I see Adrian nested object with pet's name as a key. Yeah, that's awesome. Yeah, that's the exact route we just took. It makes it easier to be able to grab stuff. We can either use if we know the name in the bracket notation, or using the .get method. What did we learn recently that we can use with the .get method is that we can put a comma and give it an optional parameter of what it will return to us in case we don't find it. So it gives us more flexibility. Okay. So next method is gonna be the get or the delete method, right? So the delete pet. So we can do define delete pet. Let's get Adrian talking for today, since he likes to lurk in the chat. You want to run us through how will we do the delete pet method, or you have any ideas?
Hello.
How's it going, Adrian? Nice for you to join us.
Hello. Happy Wednesday. Let's see. So what I did was, I don't think this was part of the thing, but I checked if the pet name was inside the dictionary, and then I just used the delete keyword to delete the pet's name from the dictionary in bracket notation.
Yeah, very straightforward. The delete, the del, I'm pretty sure it was mentioned when we had the Python crash course, and we talked about dictionaries. Yeah, objects, or as I was, dictionaries have that method of using the del to delete stuff. So we can check if what's being passed into the parameter exists within our dictionary, and if so, we'll delete it. And now we should, get some form of feedback. So delete pet, it should take as a parameter the name of the pet. So we'll do name. What do you say? Pet name, to not confuse ourselves. Pet name. We can say if pet name in self dot underscore owner. I'm sorry. Correction. Self dot underscore all pets. Then we want to delete that specific pet, and we grab it by using the pet name, right? Thanks to the way that we set up our dictionary. Else, we can raise an exception if we wanted to. Why not create an exception for that? So class, I know it's not in the README, but for the most part, a lot of this is giving us the option to decide what we want for our data members, and how to go about it. So we can, now that we got to this point in FoP, we can start, thinking on our own, right? Instead of relying too much on the README, we can actually go different routes. We have these tools in our tool belt, so we can go ahead and raise our own different exception. We can say class, what we say, non-existent pet error. Call it that. Exception. Call it pass. Else we can raise the non-existent pet error, and just say pet name does not exist. something simple like that. So if pet name in self all pets, we won't delete it, else raise that non-existent pet error. Or another way we could have done this, we say deleting pet is equal to self dot all pets dot get, and pass in the pet name, and then give it a variable. I'm sorry, not a variable, a parameter of 0, and we can say if if deleting pet is equal to 0, you could raise that exception, right? Or you could just say, whatever, print pet name does not exist. You could print that out if you wanted to, but raising exceptions seems to be the more professional way of going about this, which is why we went that way. But there's just different ways that you can do stuff. You can check it by using the 0. Else, we can delete it, right? In the same manner that we had above. You can print, or the correct way will be raising an actual error. But yeah, there's different ways of checking stuff, right? That get method allows us to use this way. But we'll keep it like this. That takes care of the delete pet. Now, next is going to be the get owner. Jasmine, do you want to run us through how we can do that?
I haven't gone that far.
Okay, well, let's read together, you and I. So it says we have a method called get owner, and it's going to take a parameter, which is going to be the name of the pet, and returns the name of its owner. So how can we do that? Any ideas? Right, so we're taking the pet name.
It's just yeah, okay, you already did that. You set the methods and doing let me see it. So just try to find the search the name, then search the pet's name, then find the kind of the value, maybe the
Okay, well,
key
let's
of
take it one step at a time. We want to search the pet name. You're right.
Yeah.
And we can do it like we did before, right? We can.
So for name in all pets.
Yeah, we want to grab the all pets. So we want to grab the owner. We can say if pet name.
Yes. Okay. Pet name.
In self dot underscore all pets. If it isn't there,
all pets.
Let's assign it somewhere so we can start grabbing it. So if pet name is in self all pets, we can do pet object is equal to self dot underscore all pets dot get. We'll grab that pet object.
And then yeah.
Okay. So we have the pet object, all right, and what's next?
Then
well,
found the key of the wait.
We want to grab
found
the
the
owner,
key,
right?
then go back to search for the owner objects, I guess.
Yeah, we want to grab the owner, yeah. Currently, we don't have a way of doing that just yet. We could directly access the self.underscore owner, but why do that? Well, we could just declare it. What kind of method can we use?
The get.
Yeah, the getter method, right? We can do a get owner method on our pet that can return to us the self.underscore owner.
Yes.
Right? And now we can manipulate that pet object using the getter method. So we can do something like if pet name in self dot all pets, My bad, my key keeps falling off, so I'm trying to put it back in place. All right. So if it exists in there, then we can return pet object dot get owner.
Yes.
Right? We can do that. I'll return pet object get owner. Now, if it's not in there, we don't have to do that. We can do. I would just do it just for sake of doing it. We can raise non-existent pet error again.
Okay.
Right? We already have that error before. We can use that here and say pet name, or we can say pet does not exist. I like that better. Pet does not exist. Right? So we already declared an error that would check if that doesn't even exist, which is awesome. That's good practice on raising the errors when we need to in our code. So yeah, that's pretty much how we can handle the get owner. That's another easy one. I think this is gonna be a little bit more difficult. This actually has to do with today's lesson, which is gonna be the JSON files. So this one, let's see who do we have in here. Oh, Jose. All right, Jose. We're going to do the save as JSON method. All right, so let's read together. We have the save as JSON method is going to take as a parameter the name of the file, and it saves it in a JSON format with that name. Okay, hold on. Takes the parameter the name of the file and saves it in a JSON format with that name. You can assume. Okay, so do you understand what number 9 is saying on line 9?
Nope, not entirely.
Okay, yeah, so we're going to create a method called save as JSON. And one of the methods is going to be whatever we want to call our JSON file. And if you remember, when we start talking about reading and writing CSV files or JSON files, we're able to, if we use the W for write and it doesn't exist, it tends to create that for us, right? Whereas if we were to use a read but it doesn't exist, we would get error. So we can kind of make a method where it'll take a name, we can pre-built it where it will write into this file and it will create it for us. And that's kind of what it's asking for us to do here. It's going to take as parameter the name of the file, and it should save it in a JSON format with that name. You can assume the extension will be part of the provided name, if any, and you can organize your JSON file however you want, right? So, how can we start that off?
So the parameter that they're putting in there is going to be the name of the file and with the extension at the end.
File name. We want to save it as JSON, so it doesn't really have to. The extension will probably be .json.
Okay.
We pretty much just we're gonna be taking a file name, whatever we want to call our file. And what is the syntax for opening and reading through our CSV files?
With open.
With open, and then we're going to take as a parameter that file name, right? So the first part of the open argument is going to take that file name, and then the next one is going to be what we want to do with it. And we want to write into this bad boy. And this should create our CSV file. So we'll say with open, the file name, pass it the W to let it know we want to write. And then we can do as JSON file. It assigns it to this pretty much name or variable called JSON file, so we can use that to call upon it and manipulate that file, right? So we have something to address it. So with open file name W as JSON file, then what? We opened it up. Now what do we do?
Not sure what else are we supposed to do to that.
We want to save so it says save as JSON, right? That means we want to save what we have in a JSON file. And if you guys remember correctly, what is our JSON file? It's essentially an object, right? When it comes to JavaScript, it's like a big dictionary. It's a big object that holds data, right? If you guys remember, like the data we've been working with these last couple of days, or essentially yesterday, uh, if you remember, like the meta and data JSON file we worked with, right? The Nobel Prize data. It was what was it? It was a JavaScript object. It was a huge dictionary, and that's what we want to do. And when working with JSON, we have to use the JSON module because it provides us with two different methods. One being loads and one being dumps, right? So how would we add this information into our JSON?
Do like JSON.dump, and then we'll dump the dictionary of pets. Well, mine is dictionary of pets. I think yours is all pets or something like that.
Mine is gonna be all pets. Yeah.
Yeah.
Yeah, we can do JSON dump. So how will we write that?
JSON underscore, I mean dot DUMP, and then parentheses, and inside of that we would put the all pets, or self dot all pets, or self dot underscore all pets.
Yeah, so we would essentially we could do JSON dot dump. We want to dump our data, which is gonna be the self dot underscore all pets. Where do we want to dump it into? Our JSON file. And it should properly work, right? That should dump everything that's in that dictionary using the dot dump method. It should format it into JSON formatted data into our JSON file. We need. I need to know what kind of. That's where the extension mattered. My bad. So going back to the line 9, right? It says save as JSON method takes as a parameter the name of the file and it saves it in a JSON format. You can assume the extension, if any, will be part of the provided name, right? So this is the name of the file, but we need the extension, right? Because typically it would look something like, file.txt or .json, but that's just going to be file name, so we can pass it it needs to have a format here, so we can do some maybe string interpolation here. And then pass it file name here, and then say .json. And that should be able to take whatever is saved in here and automatically give it a .json format, right? Everyone agree with me, or would you disagree? All right, so that should take that in there, and it opens up as a JSON file. So this would have probably not worked if we need to add the .json, or if it was to be a txt file, we could do .txt, but we're gonna do a .json. Now, let's say this should work for save as JSON. I think we can move forward. If anyone sees anything that I might have missed, please let me know. We'll move forward with the read JSON. Thank you, Jose. So we'll do define read JSON. It's gonna take in self and it says the read JSON method takes a parameter, the name of the file to read, and loads that file. So we used a dump one already. Do you want to finish this one off, Jose?
Okay. I think.
So we have the file name. It's going to be very similar to the one that we just did. It takes a parameter, the name of the file to read, and loads that file. This will replace all of the pets currently in memory. So
with open again?
with open, with open, we want to open up that file essentially, so we can do file name .json. Are you reading or writing this?
Reading.
Yeah, we just want to read through it, right? As JSON file. So we opened it up, and now what do we do?
Can we make it equal to our current all pets?
Yeah, we could definitely do that. We could do self._all pets is equal to JSON file what dot.
Oh,
My bad. It should be JSON dot load, and inside of here we'll pass it our JSON file.
Yeah.
Right.
Yep.
Everyone's still with me here? Let's make this one pretty up here. Let's add the indent is equal to 2. So when it does load it, it's now all on the line. It makes it look nice. Okay. And we got one more method. Define get all species. And this is going to take no parameters. And it's going to return a Python set of the species of all pets. Right? Research what a set is. We haven't covered it in class. Did anyone get the opportunity to look it up or research it on your own?
Yeah, I encountered it in JavaScript. It's just like unique values for each one. So it's no repeating values, right?
Yep. So since you encountered it in JavaScript, David, you want to help us out here? How will we do this? We're going to grab our pets. It's going to be pretty simple.
Yeah. Oh boy. So I didn't really get that far, but I assume you can do like return set all pets or return set and then parentheses maybe all self._all pets and then
think it's parentheses. Actually, and it might not be. Yeah, it's not. It's gonna be curly brackets. So it's a little confusing, right? Because we've been taught that curly brackets is going to be for our dictionary. So a little confusing. Just know that for the set, it's gonna be curly brackets. It's just not essentially. We're not gonna assign it directly into a value. But what's different than between this and your dictionary is you won't have any repeating values, right? So actually, stand by on that. Might be wrong. I don't want to give you wrong information. Let's see. Okay, here. So very similar to a tuple. It's unchangeable. I think that's the biggest thing here is the fact that it's unchangeable. Whereas a dictionary, It's you can change to the different items inside of it, where here you can't, right? There's no duplicates allowed whatsoever. It is unchangeable. In dictionary, we can manipulate it a little bit and change some of the stuff out. That's gonna be your biggest thing here, right? Uh, and we want to grab all species. So we're gonna have to go through all the pets, grab the species, and add them in here into our set. We're currently inside of our neighborhood pets. We're gonna want to go through every single species within the dictionary. So, uh, we can loop through our dictionary. Now, it's not supposed to. I guess that's the issue here is the fact that we can't repeat them. So, how will we go about this? We want to make sure that they don't repeat.
Don't if you try to run it as a set, wouldn't it automatically pull out the unique values or like the duplicates?
Explain.
So like if you were to run every species, like put every species, a list of every species into a set, like into the curly brackets, and then try to print it, it would only print the unique values within the set. Didn't it do that already?
That's interesting. We could attempt to do that. So let's go ahead. Let's attempt that and then see what it looks like. We can do some. How can we do? I want to do it in here. We can say.
You do for loop, like search everything's differently, then put together. I'm not sure.
We can. We can say species set is equal to open and close brackets, and then we can say for what's it called, for pet name, pet object, in self dot underscore all pets dot items. We can do species underscore set dot add pet object dot get species. We have not declared this yet. We can real quick. So we were able to grab the owner one way. So we can try to get species as well and return the self dot underscore species. So adding a getter method to that. So back to how we did this. We declared the set, species set, and then we loop through the dictionary that holds key value pairs of the name of the pet. The value was the entire object, and for us to be able to access, essentially we don't have to access both key and value. We can do for pet object in all pets dot values. This will do essentially what we want to get because we only want the values, honestly. So we can just loop through, grab the values, and then once we got that object, what's being stored in that value, we can do the get species method, and it adds it into our species set, and then we can just return species set. We'll keep it like this to see if Kara's theory is correct, and if not, then we can just come back and do. We can do a comparison, just ensure that if it's in there or not. And this should work. Give us what we're looking for. Everyone still with me? Cool. So let's look at this. So let's ignore this README for a bit, and we'll create our own, because we kind of, I don't know how that example will work for us. We kind of strayed away a little bit from it, but let's go ahead and create our neighborhood pets is equal to neighborhood pets class. It takes no parameters. Let's go ahead and add a pet. So we'll do pet 1 is equal to well, actually we don't have to do that. We could just do np, right? Because we assigned it to a class. We can do np add pet, and then the add pet is gonna take the name, species, and owner. So we can say whiskers cat. I guess there's cat species. Who's got a cat species? I'm not a cat person. Would it be cat? Should we say cat? Or should we say a cat species? I don't know, man. I'm gonna say cat, bro. I'm gonna keep it simple. We'll say cat, and then for the owner, Kara gives me cat vibes, so we'll say Kara. And
That's
then
a no.
really no, okay. Jose gives me dog vibes, so we'll give him the next one. This is gonna be Fido. Actually, Jose is a Hispanic name, and we know that we name our dogs Feudal Lies. So we'll say Feudal Lies. For the name, it's gonna be dog because I don't want to think of different. We're not talking about breeds. We're talking about species, and we'll say Jose. Oh, there's a dog. And then next one's gonna be David. He's gonna have a bird. We'll name that bird Max. It's gonna be David. Say cool. All right, so we'll Lord, you know about this. So we have our pets. That adds a pet that should raise an error if the name already exists in the neighborhood. Uh, we'll actually try that as well. We'll do np dot add pet, and we're gonna do whiskers again. We'll say that this one's gonna be a ferret, and we'll give this to Adrian. Before we move forward, let's test this out. What is this lesson? I think I'm in answer key right now. CD lesson 10. Python Pets.py. Okay, so it gets to line 66. It does raise the error. Look at that. It's awesome. Raise duplicate name error. Pet name already exists. So we know that that's working. Let's get rid of that. And it runs perfectly. No issues. We can print it out, but I'm not going to. We know that it didn't work. We'll check it out right now in a bit. Let's go ahead. We'll even delete a pet. Np dot delete pet. We'll delete whiskers, cat. Oh, what does this take actually? I'm getting ahead of myself. Just whiskers, right? Just takes a pet name. Um, Run that. I don't get any issues back. No non-existent pet error. I can assume that it's working for now. But the real one that really matters is gonna be the JSON file, the JSON one. So we can go ahead. Let's remove the delete pet one, and let's save as JSON. And let's see if that creates what we want it to. So np.save as JSON is gonna take a file name. We'll call this neighborhood pets I don't have that extension because we added that in there because we want to save it as JSON. And if we run this, we do get an issue. So we get object of type pet is not JSON serializable. Let's see it. It went up to this part here where it saved whiskers, but didn't save anything else afterwards. Why is that? Let's see it. Line 68. Save as JSON. It went through. It went into line 50. It did a dot dump.
Is it because you don't have, so you have name, you have whiskers, and then it would be formatted as like you have that, and you have the species and the owner, but you don't have like key value pairs for the species and the owner, right? So you would just have like whiskers as a cat, and the owner is Jose. So you would have like whiskers colon curly braces in curly braces fucking cat comma Jose close curly braces, and there wouldn't be a quote species quote owner, right?
I think it's because we saved it as a pet object. Yeah. It's because it's a pet object and it's not serializable. So we might have to change that up in our code, and we won't be able. That's probably why they didn't tell us to create a class for it. So we might have to refactor a little bit um, and change this up. It's not going to take a pet object. So we're going to go ahead and delete that. Let's take it step by step to try to debug what we have so far. So we no longer are going to be using the pet object. When we add a pet, we're gonna have to just straight up add it in there. So if it's not in self.allPets, we're just going to go ahead and assign it in this format where the name is going to be the key, and then we're gonna have to put this bad boy in there where it says species. Species. Yeah, it wasn't the right format. I believe that was David. Good job on that. Owner, and actually format it to how it's gonna be when we serialize it. And then that should be good here for adding a pet. We get to delete pet. It checks if it's in there. It should be able to delete it. That works. That should still work. On 30, this should work, but we're not gonna say pet object to confuse us. We're gonna say pet data. We no longer have the, actually we're gonna have to delete this because we no longer have the get owner method, right? So we want to grab an owner. So we're gonna check if it's in all pets, and if so, then we want to return the a specific item in there. And how do we go into our dictionary? I see. I'm sorry. I'm very bad with the chat, so I'm gonna check my chat. I see Adrian, you said set declaration will be species. Okay, my bad. That's pretty outdated. I don't read the chat often. I do apologize. So instead of using the get method, we're gonna have to go into our dictionary. We're gonna check if it's in there, and if so, we're gonna return self._all pets. We're gonna go into that pet using our brackets pet name. And then in there we want to grab owner, so we're gonna open up brackets again, right? Because the key that's in owner is gonna be owner, right? Because that's how the key is in there. Or essentially we could do, if I'm correct, we can do dot get here. Get owner. right? So we can do return self dot underscore all pets. We'll grab the value that's assigned to name. I'm sorry, that's my son yelling. We'll grab the value assigned to what name has by the key that should return to us its value. And if we see here, our value is an entire other dictionary. It's a dictionary within a dictionary, which is why we're able to use the .get method right afterwards. So we can use the .get. That should return to us the owner. We're going to pass the parameter owner because that's how we defined it as a key, right? So we'll move forward. Save as JSON. Stand by. Give me a second. There's a lot of noise in my place. Give me a second. All right, coming back. I'm sorry. Yeah. So let's continue. So we did the delete method that works. The get owner should work. And then the save as JSON. Up to this point, we should be able to make it all work except 45, right? Because in 45, we're using the .get species that belong to an object, and we no longer have that object. So we're gonna have to loop through again. So we're gonna say for pet data in self dot underscore all pets dot values, and then we can do species dot underscore set dot add, and here we're gonna add the pet data, but specifically the species value, right? Because it's what this is going to return is going to be the value assigned to the keys that we're looping through, right? And these values are all dictionaries, which is why we're able to use the bracket notation. One of the keys that it holds is species, so calling the species key should return to us the species value, and then we'll add it into the set. So up to this point, it should be working now. Let's try to run this. And we can check neighborhood pets, and wow, it works like a charm. All right, so that's awesome. Our JSON format is working now. Okay. Let's see. So we took care of the save this JSON. Now let's do now that we have it created, we should be able to do read as JSON. And I wonder if we can print it out so we can actually visualize it. We do self underscore all pets. Let's try to print that when we call the read JSON. So we can do np.read JSON neighborhood pets, and that should allow us. Oh, there's nothing in there. Let's see. Can we do? So we loaded the data from. Oh, I'm dumb. Okay, my bad. Because it's going to it's loading the code again. It never instantiated. We ran this as a script, so when it got to 54 to 56, it never created that new JSON. Therefore, when it saves as JSON, it saved empty stuff. So we are gonna have to do it this way, but we can have it printed out to see. Actually, no, we should be able to do this way. We'll run it once. It'll load our JSON, and then we can delete this, and we should be able to read it now, and it shouldn't. Yeah, there we go. It shouldn't manipulate our JSON file no more. We can see here printed out. It loaded our JSON data, so that's working like a charm. Let's get rid of this, and let's check out get all species. We can say print mp dot get all species, and it doesn't print it, right? So why doesn't it do that? Well, because it's an object. So we can try to print species set here. No, it's not gonna like that. Cause it's returning. It's objects. Ow. Okay. You have to give me a second for this. It's getting all species. We can return this. All species. I mean, it probably won't work anyways either. Let's get mp dot get all species. It takes no parameters. Oops. Delete and back print all species. I don't know. It's thick object has no attribute add. It's supposed to be a set. I don't think it likes this, boys and girls. Okay, we're gonna have to try something differently. Let's see if this works. Uh, I'm gonna just manually code this quickly. We'll do all species are equal to for pet data and self dot underscore all pets dot values all species dot append pet data, grab species, and then I want to return and open and close brackets. We're gonna do.
Can you do return set parentheses all species and just have it be that?
Yeah, let's try that. Maybe because it doesn't like the brackets, probably confusing it. You're a freaking genius, David. You're a genius, bro. Yeah, awesome, man. I think it just didn't like the set, man. I'm not too familiar with sets, if I'm being transparent with you. I haven't used them often. I use like tuples, but the sets is not my forte. So I have to do some research on that myself. Sets. It uses the open and closing curly brackets. It's so confusing, man. You say you had experience with it in JavaScript?
Yeah, I mean, there was like, I vaguely remember doing a problem where it was like, essentially you want to return an array that is only unique values. So instead of like, I forget what the problem was, but it's like instead of having it be an array, you have it be a set. and there was a way to specify that, and it would just like take out all the duplicate values, and it's just like another data type. So you've got like
awesome, dude. Yeah, I'm looking at it now. I mean, essentially what we just did, we added a wrapper to it. So the same way that we convert like an integer that's in a string format, and
just like a string or a float, it's just like another data type,
that's
right?
type conversion. That's pretty much the way it did. That's cool, dude. And you said it removes all duplicates. That's awesome. Yeah. All right. Cool. Yeah. Return set. Yeah. We just do that. Like, I'm a freaking nerd when it comes to stuff like this. That's cool. Yeah. I like it. Okay. Well, you saw it here, folks. That's how it's done. Thank you guys for your cooperation. We're gonna end that part of the class today, and then we'll move forward after our break into big O notation. It should be updated on the slides. I'm actually going to start recording soon. I just got the host powers for recording on what's it called, on Zoom. They sent it to me while we were teaching this. So for the most part, this is just the same thing that we've covered before, and we got to work through this together. What's next is going to be what's most important. So take 10. It's 7:07. Let's return at 7:17, and then we'll continue with the next lesson. All right, welcome back. We're going to start lesson 11 today. We just finished off reading and writing with CSV files. We're going to start something completely different, away from classes and object-oriented programming or anything around that field. And we're going to talk a little bit more about the code and what you're actually writing. I know I mentioned before stuff like time complexity and space. And some of you guys who don't know what I'm talking about will soon have an idea of why that matters and how that affects your code. It's more of an introduction than anything. If it doesn't click right off the bat, that's okay. It can be a little confusing at first, but for those of you who have done stuff like leak code, and you run your code and it tells you like how fast it ran, like space and time complexity. That's why that's what's being computed, right? Of how fast your code actually works, and we're going to talk about that and how to read your code and understand how effective it is. It's not a big issue right now, so continue doing what you are doing as you learn. This is going to be more relatable to you once you finish the immersive program, and you graduate, make it past that finish line. And as you interview, questions that you might encounter will be stuff like, how can we increase the effectiveness of this line or this code, right? What is the time complexity of this part right here, and answering that to the recruiter or the interviewer can make it look or seem and let them know that you know what you're talking about and what you're coding, and being able to read your code and know that your code is taking this long, and they tell you how can we speed this up, being able to explain to them how you can do that will take you a long way. So that's what this class is going to be about. Uh, Big O notation and common problem solving patterns. So without further ado, let's jump right into it. So how to judge code quality. Imagine we have multiple solutions to a coding challenge. How do we decide which solution is best? Anyone want to give that a go? We have different ways of doing it, and you see that amongst you guys in the product that you guys provide. Everyone does it different. We all find different ways of doing it. Uh, and how do we decide that? Well, by two different factors. Is one, depending on the problem itself, is how long does your code take to do something, and how much space is it taking up, right? And that's what we're going to find out, right? That's how we decide, or figure out how what solution or what challenge or whatever your work that you provided, which one is better, right? Big O is a mathematical notation that allows us to compare algorithms to one another, right? And here on the right side, you see a graph or a scale, kind of, and you're going to see this very often throughout this lesson. And it shows you the different types of complexities and how they're written, right? And as we see here, the fastest complexity is going to be O of 1, and that's how it's said, O of 1. This is going to be your fastest type of code, and as we go up here on this ladder, it's going to get even more complex, and it's going to take longer, right? Next going to be O log of n, then we have O of n, and it just gets worse, right? So it's harder and harder, and you're going to find out what all these means very soon. Why is this important? It's important to have a precise vocabulary to talk about how our code performs. It's useful for discussing trade-offs between different approaches to a given problem. So as mentioned to you before, you might be asked, like, is this method better than this method? Or they might talk to you or ask you about the code that you wrote. And it's important to know and speak intellectually when it comes to the code that you have written, and know that your code does something and how it does it, right? At bigger companies, you will be dealing with very large data sets where the implementation of one algorithm over another might save you a couple hours every time it runs. And we'll move forward. Example, we want to write a function that doubles the integer that is passed in, right? So we have two different functions here. The exact same function, but different ways of doing it. Here we instantiate, or we declare a variable called total with 0, and then we run a for loop for whatever in range of num, and then we add the numbers within that range into our total, and then we return total. And then here, the next one, we just return right off the bat whatever number we get, we multiply it by 2. Who can give me the answer of which one is better and why?
The second one is better. It's easier to understand, and it has to run less steps.
Yeah, okay, so easier to understand, correct. And run less steps, yes, yeah, absolutely, right? And that's where the time complexity comes to play. So take less steps means it will take less time to do something. I just turned on my monitor. Give me a second. I can't see anything by accident. Essentially, on the first one, we're running a for loop, and the for loop and how long it runs is going to be based off how big the number num is. Whereas on the right side, no matter how big the variable that's passed into this function is, it could be 2 or it can be 1,000. It will only run once. It's going to grab that number and just multiply it by 2, right? It will take one step. Whereas on the left side, the amount of steps this was going to take is going to be based off the size of that number, right? And that's what, whenever we look at the big O notation, when you see stuff like O of n is going to stand for the number of items there, or the number, the quantity, the number of steps. And here, the number of steps that the first function is going to take is going to be dictated by the parameter, right? So if it's 5, then it's going to loop through 5 different times until it finishes its code, right? So it's going to take 5 whole steps to do one thing, whereas on the right side, it's only going to take 1, no matter how big that number is, because it's always just going to multiply it by 2 one time, right? So on the right side, it's going to be an O of 1, because it's going to be a constant one step the entire time. Whereas on the left side, it's going to be O of n, right? Because n being the number of times it's gonna have to do something, and it's gonna be dictated by either 1 or it being a million, right? Whatever this number might be, n being the worst possible case. What do we mean by better? So what code is faster? Which one uses less memory? Or which one is more readable or even less lines of code? What do you guys think?
Be like less memory.
Okay. Anybody else? Your opinion?
Faster.
Faster. In reality, it's honestly a mixture of all three. Some will have a heavier weight than others. And I would say the one that probably matters the least amount is going to be the memory, right? Now, if this was 30 years ago, that might have been different, right? Because if you guys remember, at least for myself, when we were younger, buying a USB cost significantly more than it costs now. For those of you that had a PlayStation 2, like buying a memory card, that was pretty expensive back then. A memory card was like 40, $50. And now, like if you were to have to buy some kind of memory storage, it wouldn't cost $40, $50 for like 2, 4 gigabytes of memory. Memory is actually pretty cheap nowadays, right? Whereas 30 years ago, it wasn't as accessible as it is now. So memory is probably not as heavy as other stuff here, like how fast code is. I would say it would depend on what you're working with. Uh, and if I had to weigh all three of these, I would say better would probably, for faster, right? How fast your code is. I think second would be uh, the removal storage, wherever you're like how much storage you have. I would say so removal storage, because of where you're saving everything at. Uh, when it comes to the readability, that matters, of course. I think that matters definitely more than uh, the the memory than anything else. I mean, it could be fast, but if you don't understand, if no one understands how you wrote your code, if it's just a mess, then also what's the point, right? But I would say faster would probably be better, and then the readability and maybe memory third. Overall, I would say it's a mixture of all three. But that's how I would weigh them if I had to weigh all three of these. Let's talk about which is faster. If two different people run the same function on two different computers, will they get the same time? Any takers?
Yeah, no, that my inclination is to say no. Like if you have someone who's running like, an Apple II with 8 kilobytes of memory versus like a modern like 16 core processor, like it's gonna take significantly longer for the Apple II to run an equivalent program, or it might not be able to run it at all.
Yeah, you are right. I guess it would also there's different factors that play into it, right? So depending obviously on the hardware, but at the same time, without taking the hardware into consideration, right? If it was the same function, technically, the same function, uh, same type of hardware, but just different computers, it should run the exact same. Uh, but yeah, so there are different factors that you could take into consideration, right? But whenever you're just talking in regards to the complexity of the code, technically it should run the same if everything is the same, but they're different individual units. right? If that makes sense. If the same person runs the same function on the same computer on 2 different days, will the runtime of that function be the same? It won't. It probably not every time will it be exactly the same, but on average, it'd be very, very similar. Why we don't use time? Different computers will record different times. Even the same computer will record different times. So I've mentioned before, like, will it run the same? Not exactly. You will get some differences in your times, but on average, the steps is what we measure. We don't measure how fast it does something. It's gonna be by steps when we talk about how fast something is, right? And you see it with leak code, right? When you run your solution, if you run that same solution multiple times, you'll see it sometimes it'll run like in 0.92 seconds, and the other one will run in 0.87 seconds. And it won't be exactly the same. So we don't use time, but we measure it with steps, right? And how many steps it takes to do something. For very fast algorithms, the time measurements of a computer might not be precise enough. So not times, but iterations, right? So I use the word steps, but here, a better way of saying it is iterations, right? How many times it has to iterate to something to do something? And I use these words interchangeably, mainly for stuff like loops, right? So if I've mentioned before, the double function that had a loop through whatever the range of that number was, it had to go through that many iterations of what that range was, that many steps is what we measure, right? So instead of measuring time, we count the number of simple operations the computer has to perform. This number stays constant across all computers that run the same bit of code. So back to the question that we had answered earlier, technically, when speaking in big O notation, the it would run the same, right? But technically, if we're talking about time, not exactly. But that's one thing that you have to take into account when we talk about big O notation. We're not talking about time. We're talking about the steps / iteration that it's taking. So technically, with big O notation, yes, it would run the same, right? Not factoring in time because we're not talking about time. This function is only one operation, no matter how big num becomes. So num can be 5 or it can be a million, no matter what the size of num is. It will only do one operation, which is multiply that number by 2. So it will always stay the same. Comparing, so how many operations does this function run if num is 10? And what if num is 1 million? Right, so specific number isn't that important. The only thing that matters is a rough estimate. For this function, the number of operations grows roughly proportionally with num, right? That's why we use stuff like O of n being the number of iterations something has to run. Worst case, that's what it means, right? The worst case of whatever number of operation it is, and that would depend on, what exactly num is. Big O, simple definition. It's a way to formalize fuzzy counting. It allows us to talk formally about how the runtime of an algorithm grows as the input grows. Specifics don't matter as much as the broad trends of the function in question. Here you can see another graph that you'll see very frequently in this lesson as well. And this is another way to visualize different types of runtimes and how they're used. O of 1 is constant, and that's typically going to be, it's only working with one item, right? So if we were to be grabbing an item from a dictionary, that would be an O of 1 because it's instant. It's a constant time. It doesn't have to loop through anything. So O of 1 is going to be your fastest time. We'll speak about O log of n in a bit and the other ones, but let's look at what linear is. What will be a linear? Anyone take a random guess?
Maybe a for loop.
A for loop, yeah, that's your loops, right? And it's gonna be very similar to what num was earlier, right? Num could be a 5 or it could be a million. The time complexity is going to be dependent on that specific variable num, and it'll be a linear, right? It's gonna be in a line. So a for loop will be O of n. n being the size of that for loop, right? It could be n being 10 or a million. It would have to loop through every single item. Best case scenario will be, it finds what it's looking for within the first index. Worst case scenario, it would have to go through the entire loop to find what it's looking for, right? And that's what we're trying to reference here. Back to our two examples, big O of this function is O of n, right? So it has to loop through the range that num, n being the size of num, right? Big O for this function is going to be O of 1 because it's going to be a constant time the entire time. No matter how big num is, it's only going to do one operation. It is constant, regardless of what num is. All right, and that's a perfect example of what O1 is. Broad trend examples. What would you say the time complexity of this is?
Wouldn't it still be O of n?
Correct. It would still be O of n. It doesn't become O to n. Which call it the moment you put for loop in there, your code becomes O of n. N being the worst case of whatever num is. Even if there's two for loops, it's still O of n. Now, how about this one? A bit misleading. We care about number of operations and not time directly. What is the time complexity of this function? I'm dumb, Adrian. I don't know what quadratic means. If you mean square, then you're correct, right? It's gonna be O of n squared, right? So, essentially, it makes it worse. And let's explain or talk about it, right? So, it instantiates or it starts that for loop, the for I in range of num. Let's say num is 10. It's going to loop through 10. It has to loop through worst case scenario 10 times. But now we have a nested for loop. So what it's essentially saying, hey, I want you to loop through this list of numbers from 1 to 10. And then for every number, I want you to loop through again 10 times. Right? So for every item it has in that list, it's going to do something else 10 more times. Right? So now it makes it O of n squared, right? It changes from O of n to O of n squared for the size of what num is. Now it has to do something else even for whatever that same size. Right? O of n squared. It increases the time complexity. How many operations does this function run if the num passed in it is 10? It's going to perform 100 operations because for every, as it goes through 1 through 10, for every single number, it's going to do the same thing again 10 more times, right? Because it's running the same thing too in the range of num. So if num is equal to 10 and our function runs 100 times, that's n squared. Time complexity is O of n squared. Nested loops. Another big old graph, just different versions of it that you'll see here. Like I said, you'll see this throughout the lesson. You can find these on Google. It just shows you how worse they get as you go. Honestly, it's not my most favorite graph. It makes it seem like O of n squared is absolutely horrible. It's not that bad. I mean, it's bad, but it's not too bad, right? They are more common than you think. So to put it on horrible, not my favorite, right? But you want to avoid as much as possible, using for loops if you can. I mean nested for loops. My bad. I'm sure if you guys look back at your assessments, you'll probably find that some of the answers that you guys submitted were probably a bunch of nested for loops. You had just found out what for loops are, and you took it and ran with it and just used loops after loops after loops. And I'm guilty of that too. I remember I think I did like a nested for loop within a nested for loop within a nested for loop, and that is absolutely disgusting. Um, yeah, it happens, right? But we learn as we grow. Simplifying big O notation. Remember broad trends. What happens to the number of iterations as the input gets really big? So tips, constants don't matter. So two lists, right? So O2 of n. If you have two different lists, it does not matter. It's still going to be O of n. Your constant, right? Let's say that number and it was like, or we multiply num times 2, right? That was O of 1. But what if we multiply num times 2 multiple times in different lines of code? It will still be O of 1, right? Very similar to this. They're not nested. They come after each other, but the time complexity will still remain O of n, right? It doesn't get any more crazy. It's not doing any more extra steps in whatever num is. Same for this right here. If you had num times 2 on line 2, and then on line 3 you had num times 2 again, and then line 3 you have times 2 again, it will still be O of 1 because every single time it's just going to do one constant operation. We're talking about iterations, right? Not how many times you repeat it in your lines of code. So it will still be O of 1. If you had, if you can understand what this reads, 13n will be 13 for loops to the second power. That means 13 for loops that are nested. It will still be O of n squared, right? Does not matter if you have 13 different nested for loops in different parts of your code. The moment you put one nested for loop in there, it becomes O of n squared. If you use it multiple different times in your code, that's still going to be the time complexity. Right? So to visualize that, if you wrote this code here, right? This is line 1, line 2, line 3, and then line 4, you started, you re-type this in here. Again, it's not nested, but it's the same code, right? You have different nested for loops around your code. It will still be the same time complexity. So does not matter. Smaller terms also don't matter. So n plus 10 is still O of n. So if you were to do like num plus 10 there, like it don't matter. It's still one operation. Same thing here, still one operation. Here we have a nested for loop, right? So n squared is going to be a nested for loop plus 5 times n. That's going to be a constant. It's the worst complexity we have here is that nested for loop, so it's going to be O of n squared. Does this make sense, or does the notation confuse anybody right now? Okay, we'll keep moving forward. Arithmetic operations are constant time, O of 1, right? That's your basic math stuff. Variable assignment is constant. All right, so assigning your like a total equals 0 is going to be a constant time. Accessing elements in an array by their index is also constant. Same with objects in dictionary. So if you know the index of the item you're looking for in a list, then that's constant time, right? Because by knowing the index, embedded into that index is its hash location. So it'll look for it and knows where it's at with that index, right? So if you use the index, it's going to be O of 1. Now, if you do a for loop and you're trying to find it, that is going to be, what you call it, O of n, right? Because n being the amount of times you have to loop through that for loop. The steps it's going to take to find it. It'll be O of 1 if you know where it's at. And same thing for objects in dictionaries. If you were to access the element using its key, it's going to be O of 1, right? Because you know where it's at. And loops, the complexity is the length of the loop times the complexity of what happens inside the loop, right? That's your O of n squared. All right, so what is the time complexity of the following? What would you say number 1 is? So reading this is a for loop, and then you're adding 10 to it. Right, so you have 10 for loops essentially.
That's just be O of n.
O of
Right.
n.
Is that what you're getting at?
Correct. Could be O of n. Doesn't change. That's gonna be the worst. Here we have 100 of n's. That means we probably have 100 for loops here. O of n. How about number 3?
It's constant. To be like O equal to the O of 1.
O of 1, constant time, right? We know how many iterations it's gonna or what it is. It's 25. It's gonna stay the same. How about here? Number 4. O of n. How about number 5?
O of n cubed.
Yep. Cubed, right? It's the nested for loop within a nested for loop. How about number 6, function with one set of nested loops? It's a function though. What would you say it is? Somebody besides Carol, please.
O of n.
O of n, right? O of n. Even if it's just one nested loop. I'm sorry, no, not O of n. My bad. It's nested, right? So O of n squared, right? It has a nested loops. If it was just a for loop, it'd be O of n, right? The moment it becomes nested, you have two loops there, one inside of another. It becomes O of n squared, right? Uh, function with 10 unnested loops.
O n.
O of n. Let's do something real quick. Where do I reset this? Okay, so just to ensure that we all understand, I don't want to lose people as we go, right? O of n squared. How do I? Oh, my bad. Yeah, buddy. So O of n squared, right? What does that say? N is going to be the number of iterations of what a code has to do, right? So if we had, so that's O of n squared. Let's say O of n, just O of n. Bro, grab it, bro. Jesus. O of n is your regular loop, for loop. O of n squared is going to be your nested for loop. Let's talk about these. I'm only going to specify it mainly because I know people get confused with these two. O of n, it doesn't matter what O of n is, right? N can be 5 or it can be 10, right? N is going to be your list, right? That's going to be of so many items in there. Can have 5 items, right? Or it can have 10. Regardless of what it has, it will always, N stands for number of iterations in here, and worst case scenario. But we can't confirm what the quantity of it or how long it's gonna have to take to do something. A for loop will always take O of n, the number amount of operations inside of it. And I say n being the worst case scenario because that's what it is. Right? The longest this could possibly take, if it was in regards to this list right here, if we were doing a for loop, would be 10 operations. Right? When we talk about the big O notation, we're talking about worst case scenario. Worst case scenario is we're gonna have to loop through this bad boy 10 times. Best case scenario, maybe once, but that's not what we're referencing here when we talk about O of n. We're talking about worst case scenario. O of n squared, right? Another way of writing this will be n times n. This will be a different way of writing this. Essentially, actually, then that means we'll go back to the slides in a bit. O of n squared is it's multiplied by another n, right? So that means if I wanted to do a for loop here for a number in list, print number, a regular loop is O of n because it's only going to do as many iterations as whatever is inside that one loop. But the moment we start doing nested for loops, we can say for number in list, print, no, let's say, for number in list, for I in range of number, print number. This is what this is saying, right? Essentially, it's going to loop through worst case scenario throughout the entire list, and for every single item, it's going to do something this many times, right? So for every single item in this list, it's going to do this operation. Who knows how many operations this for loop is? I don't know. Worst case scenario, it might be 100 times, right? But if for every single item in this list is going to do something else, therefore multiplying the amount of times of what it's doing, right? So this one should be O of n, not O of n squared, because we know what 100 is. If this was n times n, it would have been O of n squared. Same thing here, still the same. So everything's still good. Do you guys track what I'm putting down up to this point? Is anybody confused with the big O notation? Jasmine, you're looking up like what's going on.
I'm good, thank you.
Okay. Jose, good?
Yep. That makes sense. So it doesn't matter how many of the same, like whether it's a single loop or a nested loop or, like a polynomial, anything, as long as it includes one, it doesn't matter if it includes multiple, it's still, whatever that the
Correct.
base. Okay.
Yep,
cool,
it
cool.
increases the difficulty already.
Cool.
All right, so what is the time complexity of the following function?
Just regular ON.
I want to say, actually, now I think about it, it's a little difficult. Let's see. The range is gonna be dependent on whatever num is. Uh, but it's not always gonna be a set number. It can always be multiple iterations. So, yeah, it's probably gonna be O of n, right? Because it's doing multiple iterations based on the size of what num is gonna be. Worst case scenario, right? We're talking about worst case scenario. So yeah, it's gonna be O of n. Good job, Jose. Another quiz. What is the time complexity of the following function? Anybody?
Is it two loops because min is actually a loop itself?
That's actually a very good observation. Uh, but what is it? That's actually pretty good.
But it's not nested, right? So it's technically running the min first and then the for loop.
Yeah, because not gonna run a certain amount of time for every item in that for loop. It's gonna go in here for I in range of 1, and then inside of here, it's only gonna check min one time. So it's
So
not nested.
is this just like having two ONs, like two regular ends, not n squared,
Yeah,
right?
it's almost like having two ends, correct? Right, because it's not gonna run. It's not gonna run the min uh method multiple times. It's only gonna run it one time whenever the for inner range method runs. Uh, so it's still we consider O of n, but it's what is it doing here? It's gonna always grab the smallest number. It's either gonna be dependent on what num is or what 10 is. What do y'all think? Jose?
I still
See,
go with ON.
O of n?
Yeah.
Why?
Just like I said, it's not actually nested, so it's only once it does it once, that's it. So it's like looping through it, and once we have that set numbered, I mean, like I said, it just sounds like two ends, not an n squared.
Yes, but you would be right if it wasn't for this 10, right? What does the min do? It's gonna grab the smallest number overall. So no matter what num in, it's restrained to a constraint of 10. Uh, so it ends up being O of 1. Correct, Adrian. Oh, Adrian got it before you guys. Yeah, so it's constrained to the 10 because no matter how many or how big the number of num is, it's always going to choose the smallest number being it's going to be 10, right? So if it goes higher than 10, it doesn't matter because it's going to grab 10. So it's going to be no more than 10. Does that make sense? Dang, Adrian doing pretty good. +1, obviously. But yeah, so with the constraint of 10, no matter how big num is, it's never going to matter because it's not going to go past 10. 10 being its constraint. What is the time complexity for the following function?
Just one question. Would that make it, since it can be less than 10, would that make it O of log n?
No. Do you know what O of log n is?
Don't have a straight idea. I can't give you a clear answer, but I have a thought of what it was.
Not exactly. We're about to get to it in a bit. I like it though. Good try. What is the time complexity of this one? What is the time complexity of total equals 0? It's gonna be a constant, right? We said assigning variables are constants. But line 2, 3, and 4, what would you say this is? O of n. Correct, Adrian. I see you in the chat. Yeah, O of n. All right, the amount of iterations is going to be dependent on the size of the array. It might have one item, it might have 10 million. It doesn't have that constraint that the other one had that was 10. This one, it has no limit, right? It could be anything between 1 and 10, or like 10 million. It don't matter. And then, oh, my bad. You're wrong. I completely overlooked the part. But afterwards, we're doing something here, bro. We have a nested for loop, right? So it becomes O of n squared, right? Because for every item inside this array, the size of the item, we're going to loop through that item and do something. All right. This could be 1 through a million. And then if it becomes a million, then it's gonna do for that for num in a million, right? For whatever number it gets to. The worst case, it's gonna be LM is gonna let's say if we're doing a range from 1 through whatever the length of array is. Array has a million items, right? That means it's gonna go to 1, 2, 3, 4, all the way to a million. And then for every single of that number, it's gonna do something. So it'll be O of n squared. Space complexity. We still got 10 more minutes. Actually, we'll take a break here. It's 8:05. Let's take a 10-minute break and then we'll finish off the day. I gotta take the dog out. I see that I have to go. Thanks for lesson. All right, David had to leave. It's okay. All right. Let's get back into it so we can finish today's lesson. It is cold out there, man. Whew, okay. Can you guys see my screen? Good to go? All right. So far we have focused on time complexity, but how we analyze the runtime of an algorithm as the size of the input increases. We can also use big O notation to analyze the space complexity of an algorithm or how much additional memory the algorithm uses when it's executed. The question, what is the time and space complexity of your solution, is actually asking for two big O values. One for time and one for space. Cool. So all off the slides. I hope you guys are following through with me. So an example, Space complexity deals with how many variables or elements you are storing or keeping track of, right? Very similar to time, where we're talking about iterations. Here we're talking about how many variables or elements. Look at the function below. What is space complexity?
So it's
Anybody?
just look, cares about like where it's storing the values.
How much space is taking up?
So, and it's still big O notation.
Mm-hmm.
So would it be O1 in that case?
Yeah. O1. Just that total. How about this one? What is the space complexity for the following function? They create a new list which is empty, and they go through a for loop. So not talking about the time complexity, but we're talking about the space. What is the space complexity for this?
Hey Roger, can you answer what he asked in the Adrian asked in the chat? I also wanted that clarification a little bit.
Time complexity equals loops. Space complexity equals variables utilized. Time complexity is how many iterations, right? So it equals how many steps, iterations, how many times you had to do something. Space complexity is how many variables are like assigned or utilized, or how much space is used, right? Does that make sense? O of n. Correct. So it's going to be O of n. Multiple different locations that it's going to be stored in the list. Is all going to be dependent on the size of the array for which they're looping through, right? For num in R. So O of n. What is the space complexity for the following function? Anybody?
Is the O1?
Yeah, O1. They're not really taking up any space. It's mainly the time that's being calculated here. Nothing's being saved to any variables, nothing like that. How about this one? All right, think about the last one we just did.
I'm with Adrian on that one.
It's gonna be O1, right? It's not saving anything else, not taking up any space whatsoever. The complexity for time will be different than this one exactly. Well, I mean, they're actually pretty much the same if you think about it, because of the constraint of 10. But this one is O1 because it's not saving and taking up any space. Right? We're not saving any variables into no list, not taking up anything else. Space complexity tips. Remember broad trends. What happens to the number of variables, the elements being stored or tracked as the input gets really big? Most primitives, right? What is the difference between primitives and non-primitives? Who can tell me that? It's gonna be O1. Why? Well, because primitives are, for the most part, right? the difference between primitives and non-primitives is that primitives are immutable, where non-primitives are not. Right? Your primitives are your booleans, right? Your true or false. The numbers, so integers, undefined, no, but strings, right? Strings being one of them. And your non-primitives is your dictionaries, your list, and stuff like that. Those are mutable that you can add stuff to and change. So if you can't change it for the most part, then they should just be a constant space, right? Because they only take up one area, right? So if a number is a million or one, it's still constant space. It's all stored in the same area. Strings require O of n space, where n is the string literal, or I'm sorry, the string length. Why is that?
Because depending on how long the string is, depends on how much space it's going to need.
Yeah, I don't want to get too much into this class because it's going to be taught in the immersive program as well. But it's not all saved in the same area, and you'll find that out yourself later. Reference types are generally O of n, where n is the length for arrays or the number of keys for objects. You see this graph again. I'm not gonna talk about it any longer. Logarithms explained. So now talking about logs, something that Kara brought up earlier, right? So we had discussed some common complexities like O of 1, O of n, and O of n squared. Sometimes big O operations involve more complex mathematical expressions like O of log of n or n log of n. So what is a log or a logarithm? It is the opposite of an exponent. And I'm not lying to you, this took me a while to kind of understand myself. But it's pretty much just the opposite or backwards of what the exponent would be. So what you call it? The exponent here, 2 of 3 is equal to 8. It's pretty much the exact same thing. It's just written differently, right? So log of 2 for 8 is going to be 3. And that'll make a little bit more sense once you see it. So log base is 2 of 8. Right? So pretty much how many times does 2 go into 8? I'm sorry, I said that wrong. 2 times 2 is 4, times 2 is 8. Does that make sense? I'm sorry if I don't explain myself correctly, but I'll correct myself as I catch it. Or if you guys have an issue with how I say stuff, please let me know and I'll try to rephrase it. In the same concept here, the explanation is right. 2 to the third power will end up giving you 8. It just pretty much written differently. Logarithms continue. There's a lot of log bases, not just base of 2. But for our purposes, we would treat all logs the same. We just care about the big picture. And here's a better understanding of how to take into logs. So the number 8, right? The first iteration, which is why log base of 2 of 8 is going to be 3, right? You divide 2, you divide 8 by 2 once, and it'll give you 4. That is the first iteration, right? And then you grab that number, you divide it by 2 again, it cuts it down to 2. That's going to be your second iteration. And then you get what's left, divide that by 2 again, that being your third iteration. Therefore, log of 8 is equal to 3, right? Because how many iterations it took for that. And it'll make more sense once we start visualizing it. A rough rule of thumb, the logarithm of a number measures the number of times you can divide that number by 2 before you get a value that is less than or equal to 1. So don't worry about anything else besides 2. This can be what we're really focusing on, right? Just the 2. So the only base you have to worry about is just 2. So how many times can we divide it by 2? Okay. Why are logs important? Starting and searching algorithms have logarithmic time complexity. We'll get to the algorithms later. Some of them are more efficient or better than other algorithms. Most notably, binary search was a common search algorithm used in technical interviews. Recursion. How many of you guys are familiar with recursion? Kara, I'm not surprised. A little. Okay. Yeah, it's very difficult to understand at first. Personally, it took me forever to understand it myself. To understand recursion, you have to know recursion, if that makes sense. Logarithmic time and space comes up periodically, so it's best to be familiar with it. You don't have to be an expert, however. All right. So, like I mentioned to you guys before, no one expects you right now to be an expert. This is more of an introduction to get you started, to get you started on thinking of what your code is doing exactly, right? And understanding that things like the time complexity actually matter. So whenever you do start coding and you decide to do that triple nested for loop, think twice, right? Uh, and get better habits at your code. Which is why I enjoy using stuff like dictionaries instead of my list. It's easier to access. N minus one. I don't know what you said, Adrian. Not exactly. It's recursion is like when a function pretty much calls upon itself to do the same thing. You'll see. I mean, I can see what you're trying to get at, if I'm correct. Uh, but we'll talk more about it. There'll be a whole class on itself. All right. So in a nutshell, big O notation is used to analyze the performance of an algorithm, right? So time complexity is going to be your iterations slash steps of how many times it did something. Space is how much room it took, right? How many variables have we declared? How much stuff is saved into a dictionary or a list, right? How much space is it taking up? Big O notation gives us a high level understanding of the time and space complexity of an algorithm. It does not care about precision, only about general trends as the input gets really, really big. The time and space complexity of an algorithm depends only on the algorithm and not the hardware used to run. So that goes back to David, right? When we were talking about the different practices to take, which one will run faster, technically, when speaking in the terms of time, actual real time, then yes, one's going to run different than the other. But when talking about big O notation, that time complexity is different, right? And that's important to know the difference between both of them. Is he still in here? I think he left earlier. I think he left. That's okay. Study this graph. You only have to. The ones we're gonna really be focusing on these three right here. Maybe sometimes we'll deal with some of these. Not too crazy. Dictionaries in terms of big O. So here is the answer to some of the questions you might be having. All right, so dictionaries insertion. All right, so inserting something in a dictionary is going to be O with one. Why? Because whenever we assign something to a dictionary, we automatically declare a key and then give it its value, right? We don't just you don't really have to say anything specific about where it goes. It's in key value pairs, right? Unlike an array, if you want to insert something in the middle of an array, you kind of specify the index between, right? Or where, after, before, whatever method you decide to use, it's a little bit different. Removal for dictionaries is also going to be O of one, right? Because we call it by the key, so it's in key value pairs, and how we access it, same concept, O of one, thanks to the key value pair concept. Searching O of n, right? So when we did stuff like for key and my dict dot keys, right, or on items, and we were looping through it, that's searching. We're looking through it in the same manner that we would a list. So therefore, it's O of n being the amount of key value pairs that dictionary it has. And then you see that here moving forward, we have dict.keys, .values, .items, same concept, right? That's where the why it's O of n, because we're searching in it. If you were to return, for example, if you were to get like all keys is equal to dict.keys, right? You assign the dict.keys into a variable and you print it, the variable my keys, you will realize that it returns to you a list, right? So .keys, .values, .items returns a list, which is why it's going to be O of n. That's that's what it's doing underneath the hood. It's actually converting it into a list and looping through it, right? That's just something to know for your own knowledge, right? So list insertion at the end is O1, right? Because if you were to append something, you insert at the very end. It doesn't have to loop through anything, search through multiple items. It knows where the end is at. It just puts it at the very back. Same concept with at the no, not at the beginning. It's gonna be different. Why? Why is it O of n when we start it at the beginning? Because that's to move everything, right? If you had a list of 1 through 5, number 1 is at index 0, number 2 is at index 1, and then if you wanted to put the number 10 at the beginning, you would shift everything. Every single number would have to be shifted once to the right, because now you added something at index 0, so now everything shifts indexes 1 over. Therefore, it would be O of n because it would do so many iterations depending on the size of your list. Removal at the end, same concept. When thinking about the insertion, same way for the removal, right? You can remove whatever is at index -1, which typically grabs what's at the very back of your list. Accessing will be O of 1 if you're using the index, right? So if we access our list directly, we're usually using our bracket notation with the index being called within it. And that's how we access stuff directly. But if we didn't know what we're looking for, we would typically loop through it, right? That would be searching. Searching will be O of n. Sorting will be log of n. And we'll talk more about that later. Slicing, it's going to be O of n, depending on the amount of items you're trying to get back. Filter, reduce, map is going to be one of your higher order functions. That's going to be O of n because it's going to be dependent of the length of your list again, right? So if we were to do the dot filter method or the filter method on a list, right, you would have to go through the entire list looking for whatever you're trying to filter through. Same concept for reduce and map. Those are one of your higher order functions. Big O notation questions up to this point.
So just beyond nested for loops, or nested loops, if you were to use like filter or map inside of a for loop, that would make it, as far as time complexity goes, that would make it O of n squared, right?
Correct, right? Because it's O of n on itself, and if you nested that within it, and you're going through that many iterations for whatever item you're using in that loop, it's O of n squared.
Got it.
Anybody else? Awesome. Comments, problem solving patterns. So keynote, not the silver bullet to solving all coding challenges, just some helpful patterns to be familiar with. If who follows Neat Code and on YouTube? Anyone know who Neat Code is? NEET? No? Okay. Well, Neat Code has a nice little roadmap that he created himself about how to navigate through LeetCode, right? For those of you who have used LeetCode, I want to say most of you probably have. I know you guys are introduced to Code Awards when you start off. LeetCode seems to be the more popular one that most industries use. LeetCode, it can be a little overwhelming, right? At first glance, when you go through it, there's just so many problems in all types of stuff. And Neat Code provides you a little roadmap of how to start off, and he breaks it off into segments. And some of the segments they use are like, pointer problems, sliding window problems. And I say that because these are some of the more common problem solving patterns that you'll see. And this roadmap will break it up in segments like that, so you can practice these methods with the lead code problems that are most commonly seen uh, around the industry when it comes to interviews. And I see Adrian, you said see individuals here and there. Yeah, it's very popular for solving some of these problems. We'll cover these 4 patterns. There's many more that you'll see out there. So just be aware of that. Frequency counter pattern. This pattern uses dictionaries to collect values and frequencies of elements. And we can break that up. We can dissect it a little bit here. This is a common thing to use when it comes to dictionaries. You see we have on line 1, we have a list of different integers ranging from 16 to 19. And then some of them are duplicated. We have 16 there twice, 17 there 3 times, 18 twice, and then 19 3 times. And I'm assuming that the question is trying to find how many times an item repeats itself. And the way it goes about it is that it initiates an empty dictionary here called frequency that it's going to use. I see your message, Adrian. Should you become proficient with those? Yeah, I mean, you should know them at the very least. They're very popular. So those are very good ones to start off with to learn how to do. Yeah, so back to the problem. We see here on line 3, we got an empty dictionary. And they're going to use this dictionary to be able to sort their stuff out, right? It initiates a for loop to allow them to start accessing the items within this loop. And as we access the items, it's immediately going to sort it into the frequency, right? So it does frequency, assigns that number as a key, and then it uses a dot count onto the list itself to count how many times that item comes out, and it assigns that as a value. And then it goes ahead and does another for loop here to be able to print out everything in there multiple times. Now, I wouldn't do this. This isn't the most effective, but what I really want to point out is the fact they're able to use the dictionary to assign stuff. Here, the dot count is essentially a nested for loop. Why? Because the dot count is going to loop through it and count every single time that thing appeared in there. So this method wasn't applied effectively, unfortunately. What I would do if I could do this differently would be to check if it's in your dictionary, right? Because we have the key already. It would access it. O1, accessing your item using the keys. It's O1. So we would check it. And then if it wasn't there, then we would grab that key, it increased its count from its value. But if it wasn't in there, then we would just assign it there with a key value pair. Does that make sense? So essentially, if you ignore line 6 or 7, you would do for items in list. If frequency bracket items is in your frequency dictionary, then do plus equals 1, right? That means it already existed in there. You've encountered it before. You're just going to increase the count. Else, you would assign it, and you start the count at 1, right? Because that means we've seen it once. And that's a really nice, effective way to keeping track of stuff using dictionaries without having to use methods like dot count. Dot count essentially it does another for loop. It defeats the purpose of all this, right? It essentially becomes O of n squared. Here is one of them. We're going to save this for tomorrow. I don't know if we'll have enough time. I would like to sit down and code along with you guys. So we'll stop here before the practice problems. If you guys want to, you guys can try them out. Tomorrow we'll do a code along and whatnot. To let everyone give it a try. You'll see here most of what the lessons are consist of are trying out the patterns and doing some small little coding challenges to help you use the data algorithms. Right, so it's gonna be very interesting. Tomorrow or tonight, I'm going to share a book on the Slack channel. And it's a book about data algorithms that I used while I went through the full stack immersive program. And it's probably one of the best books I've ever read when discussing algorithms and data structures. If you struggle with big words, then this book is for you. That was me. I couldn't really understand, especially concepts like recursive, or recursion. Then I read this book and it helped me understand it. So I'll share that with you guys, and hopefully that can help you understand. I would just read up on whatever we cover that night, the following day prior to class. That way you can kind of like ensure you understood the day's previous lecture, and that way you can begin the next day ready to learn something new. But I would definitely check out that book that I'm going to send on the Slack channel and read it. Right, it's a very easy read. A lot of big words. It looks like a lot of pages, but the big words fill up most of it, and you'll go through it quickly. I promise you. And it has cute little pictures that you can admire. So I'll send it to you guys. But that's pretty much all I have for you guys today. I don't want to start something and leave halfway, so I'll leave it at this. Uh, I'll stay here for another couple minutes if anyone has any questions. If not, then you all have yourself a good evening.